morning friends, today we are going to discuss more numerical asked in Neet exam. Now, one more is ray of light travel in a medium of effective index and it indicates it incident on a surface in contact with A at 45. For what value of n, this ray will undergo the total internal reflection. Right? Here, what is given? Ray of light travel in a medium having the effective index is n. It incident. Just a minute. It incident at a surface in contact with A at 45 degrees. Now, for what value of n, this ray will undergo the total internal reflection. We know that for total internal reflection, condition is that the n must be greater than or is equal to 1 upon sine c. 1 upon sine c. Here the critical angle is given the 45 degree. Therefore, sine c is equal to sine 45 is equal to 1 upon 2. Therefore, n must be greater than or is equal to root 2. We substitute the value of sine c here. So 1 upon root 2, therefore only root 2. Root 2 is equal to, therefore n greater than or is equal to 1.415. That is greater than 1.4. Therefore, approximate value of n is 1.50. That is our answer. Now, again, this numerical would suggest ray of light is traveling in a medium having the effective index is n. Now, it indicates incident at a surface in contact with A at 45. Already, this ray of light is incident on the surface at 45 degree angle. Right? For what value of n? At the same angle, for which medium having the different value n, then this, at this 45 degree angle, incident angle, this ray undergoes the total internal reflection. That means the value of the critical angle is given. So condition for the total internal reflection is that n is greater than or is equal to 1 upon sine c. Here we take the c as 45, sine 45, 1 upon root 2, substitute here. Therefore, n must be greater than or equal to root 2. Value of the root 2 is 1.415. Therefore, the n must be greater than or is equal to 1.50. Clear this? Okay. Now next, that is depends on the theory. Which of the following phenomena does not depend on total internal reflection? That means here the four phenomena are given. In which phenomena of the following the total internal reflection does not take place? The first is given wave of optical fiber. Already we discussed about the optical fiber, how the electromagnetic waves, that means the beta wave, passing to the optical fiber under the effect of the total internal reflection. That means in an optical fiber the total internal reflection phenomena takes place. Now third, mirage formation in summer. In summer season we saw that the mirage effect. Already we discussed in total internal reflection. The first effect is mirage effect. Mirage formation in summer is due to the total internal reflection because whatever the ray coming from the object continuously undergoes the total internal reflection and enter to the eye of a person. Okay. Therefore, the total internal reflection takes place in A and C. Now D, sparkling of a diamond. Already we discussed the diamond shown the bright due to the total internal reflection. Therefore, in phenomena A, C and D, the total internal reflection takes place. While in B, real and apparent depth of vessel filled with water. So in this, when the one container or the vessel is partially or fully filled with a liquid or the water or the other medium, and we are observing the bottom of this vessel. At that time, the phenomena of refraction take place, not the total internal reflection. Therefore, B is our answer. This phenomena is not depends on the total internal reflection. Right? Here the one point. Now next is radius of curvature of a bioconvex lens is 20 centimeter and object of 2 centimeter height is placed at 30 centimeter from lens. Now listen, here the radius of curvature of a bioconvex lens is given. That means the both radius are given. I1 is same 20 centimeter, while the I2 we consider as minus 20 centimeter. Height of an object HO is given the 2 centimeter, and object of the 2 centimeter height is placed at 30 centimeter. That means the object distance U is minus 30 centimeter given. Then which option represents the image? Here the different form of the image, format image are given. First is the virtual EF of height 1 centimeter. Right. Second is virtual EF of height 0.5 centimeter. Third, real inverted of height 4 centimeter. D, real inverted of height 1 centimeter. Right. So how do we find out? So keep in mind that here the focal length of a bioconvex lens is not given. So first our aim is to find out the focal length. And for focal length here, the effective index of a material of a lens is required. Actually, that is not given in the exam. But generally, the lenses are made from the glass. Therefore, we consider the effective index of a glass is 1.5. Therefore, we are using the equation 1 upon F is equal to N minus 1 into 1 upon I1 minus 1 upon I2. So it's equal to N 1.5, that means the 3 by 2 minus 1. Here, 1 upon radius of curvature, both sides are same. One we consider positive, second is negative. Why we consider positive, negative? Already we discussed in numerical and also theory. Okay. Therefore, 1 upon 20 minus 1 upon 20. And as we simplify, we obtain the focal length is 20 centimeter. Focal length is 20 centimeter. Simplify yourself to find out the focal length of a bioconvex lens. Okay. Now we require which type of the image is formed. Here the magnification is given, that means the height of an image is given. To find out the height of an image from the magnification, we require the image distance. Image distance is not given, therefore, from equation of lens, from equation of lens, 1 upon F is equal to 1 upon V minus 1 upon U. 1 upon V minus 1 upon. Substitute the value. F is equal to 20, U is equal to this. So first thing here, 1 upon U is equal to 1 upon F plus 1 upon U. Therefore, we obtain the V is equal to 60 centimeter. Image distance we obtain 60 centimeter. Now, we know that magnification M is equal to HI upon HO is equal to minus V upon U. Using this concept, we can find out the height of an image HI. HI is equal to minus V upon U into H. So as a result, we obtain the HI is equal to minus 4 centimeter. Minus 4 centimeter. There is the height of an image. Therefore, our C option is there. real inverted. Where the negative sign represents the image is inverted. Therefore, real inverted of height 4 centimeter image is obtained. Therefore, image is real inverted of height 4 centimeter. Clear this? So for this step of the numerical, the calculation is quite lengthy. First, we have to find out the focal length of a convex lens. Radius of curvature of bioconvex lens are given the 20 centimeter. So using this equation, lens maker's equation, 1 upon f is equal to n minus 1 into 1 upon r1 minus 1 upon r2. First, we find out the focal length of a lens. Now, we require the type of image obtained. For that purpose, the image distance is required. For that purpose, using the equation of lens 1 upon f is equal to 1 upon v minus 1 upon u. Take the u this side, therefore we obtain the value of image distance. After finding the image, now the magnification m is equal to hi upon ho is equal to minus v upon u. Minus v upon u. Therefore, hi is equal to minus v upon u into ho. Now v is known, u is already given, right? And ho is also given. So here the magnification is, sorry, the hi height of an image is negative. Therefore, the inverted image is obtained. And this image is real. Therefore, real inverted image of height 4 centimeter is obtained. Now next is a prism of refractive index n1 is equal to 1.5. N1 is equal to 1.5 and prism angle A1 is equal to 15 degrees. Is ends with another prism of refractive index N2 is equal to 1.75. This combination gives the dispersion of light without deviation. That means the deviation of here the two prisms are arranged in this manner. One and second is just direct. So whatever the light is incident, so there is the reflected again incident on this. So direction of incident and inverse ray both are same. Both are same. There is the prism 1, prism 2. So dispersion of light takes place, but deviation is 0. Dispersion is 0. Therefore, the total deviation delta is equal to delta 1 plus delta 2 is equal to 0. But we know that delta is equal to A into n minus 1. A into n minus 1. Substitute here the value of delta 1, delta 2. Therefore, A1 n1 minus 1 plus A2 into minus 1 is equal to 0. Now listen. A1, N1, N2, 3 values are given. We have to find out the prism angle for second prism. Therefore, A1 is equal to 15 degrees. N1, 1.5 minus 1 plus A2, we have to find out 1.75 minus 1 is equal to 0. Simplifying this equation, we get the value of A2. A2 is equal to minus 10 degrees. Why we obtain here A2 is negative? Because here the second prism is inverted. Here negative sign indicates another prism is inverted. Another prism is inverted. Clear this? Okay. So keep in mind that the deviation delta, total deviation delta is given the 0 without deviation. Therefore, deviation due to the first prism is delta 1 and deviation due to the second prism is delta 2. Delta 1 plus delta 2 is equal to 0. And we know that the angle of deviation delta is equal to A into n minus 1. Right? So, using this concept, delta 1 is equal to A1 into bracket n1 minus 1 plus delta 2, A2 into n2 minus 1 is equal to 0. Now we substitute the value of A1, N1 and N2. We obtain the value of A2. Now A2 is obtained negative because the second prism is inverted compared to the first prism. Therefore, we obtain the answer is A is equal to A2 is equal to N equal. Clear this? Okay. Okay friends, now the new numerical. A converging light beam incidents on a diverging lens. After passing through lens, rays intersect at 15 cm behind the lens. Rays intersect at 15 cm behind the lens. If lens is kept away, then these rays intersect at 5 cm. Now, what should be the focal length of this lens? Now, what this numerical suggests here, the diverging lens is given, that means the concave lens is given. There is the axis of a lens. Now, the ray incident on a lens are focused at 15 cm distance from the lens. So there is a first focal point S. So this distance is given the 15 cm. Now we keep the lens away. That means we are slightly shift this lens behind this side. So what's happened? This beam is focused 5 cm distance. That means focused at S dash distance. There is a 5 cm. Therefore, the remaining distance from the lens is 10 cm. This distance is. That means the distance of S dash is 10 cm. So in other words, yes, we kept the object here at S dash point. So rays are reflected by the concave lens and image is obtained at S point. S dash is the object. The ray coming from the S dash incident on a concave lens and image is formed at point S. Therefore, our object distance is 10, image distance is 15. We have to find out the focal length. Right? Therefore, from figure, U is equal to 10 cm, V is equal to 15 cm. We require the focal length of a lens. From equation of lens, from equation of lens, 1 upon F is equal to 1 upon V minus 1 upon U. H is substituted the value. V is 15 minus 1 upon F. Therefore, we obtain F is equal to minus 30 cm. Clear this? Where is in numerical? Here the converging light beam incident on a diverging lens. Diverging lens, that means the concave lens. So this lens, this beam is focused at 15 cm distance behind the lens. Right? Okay. SV slightly if the lens is kept away. So what's happened? These rays intersect at 5 centimeter distance. That means the point of intersect is shifted by the 5 centimeter distance from the lens. What is the focal length of a lens? For that purpose here the figure is shown. So as we consider the S dash is the object. S dash is our object. So with help of a concave lens, this image is formed at point S. S is our image. Now image distance is given 15. Now object distance is 15 minus 5, that means the 10 centimeter. By using the equation for length of lens, 1 upon f is equal to 1 upon v minus 1 upon u. Here u is not negative because this direction. Distance is measured in the direction of incident light. Therefore, f we obtain minus 30 centimeter is the focal length of a concave lens. Clear this? Okay. Now the next numerical asked in 2013. Earlier it asked in 2011 main exam of all India PMD test. Right? Okay. Now next, a plano-convex lens fits exactly into a plano-concave lens. Now listen, here what is the diagram? There is the plano-convex lens. Is fit exactly to the plano-convex lens. Plano-concave lens. There is the plano-convex, there is the plano-concave lens. The plane surfaces are parallel to each other. These plane surfaces of both lenses are parallel to each other. If the lenses are made of the different material of refractive indices mu1 and mu2. Here the effective index of material of this is mu1, and here the effective index of material of this lens is mu2. And as the radius of curvature of curved surfaces of the lenses, then the focal length of the combination is, what is the resultant focal length? So we know that the resultant focal length 1 upon f is equal to 1 upon f1 plus 1 upon f2. Right? The resultant focal length one upon f is equal to 1 upon f1 plus 1 upon f2. Second is the convex. So a concave, there is negative f1 minus 1 upon f2. f1 and f2, and it has the focal length is f1. Now concave lens is the focal length negative, convex is the focal length is positive. Okay. Now how we obtain it? We know that but 1 upon f is equal to mu minus 1 upon r1 minus 1 upon r2. But r1 is equal to r and r2 is equal to 0. R2 actually there is a parallel line, so its focal length is infinite. It is infinite. Clear this? Okay. Therefore, our answer is that means the relation between the focal length f1, 1 upon f1 is equal to, or the 1 upon f, mu minus 1 upon r. Therefore, f is equal to r upon mu minus 1. R upon mu minus 1. Therefore, the value of f1 is equal to r1 upon mu1 minus 1, and f2 is equal to r2 upon mu2 minus 1. Therefore, 1 upon f is equal to 1 upon f is equal to mu1 minus 1 upon I1 for the R minus mu2 minus 1 upon R. If is simplified, we obtain the resultant value of focal length I is equal, f is equal to I upon mu1 minus mu2. So C is the answer. Again, by using the concept of the combination of lengths, the resultant focal length 1 upon f is equal to 1 upon f1 plus 1 upon f2. One is plane of convex and second is the plane of convex lens. Convex lens has, the concave lens has the focal length is negative, while the convex has the focal length is positive. F1 is the focal length of convex lens, F2 is the focal length of concave lens. Concave lens has the negative, therefore 1 upon f1 minus 1 upon f2. Now from lens maker's equation, 1 upon f is equal to mu minus 1 upon I1 minus 1 upon I2. Right? Okay. Here the second surface is plane. Therefore its radius of curvature is infinite, therefore its value is 0. I1 we take as R, therefore 1 upon f is equal to mu minus 1 upon R. Therefore f is equal to I upon mu minus 1. Therefore f1 is equal to I1 upon mu1 minus 1 and f2 is equal to I2 upon mu2 minus 1. We substitute the value of f1 and f2 here in this equation. Therefore 1 upon f is equal to 1 upon f1. F1 is this. Therefore mu1 minus 1 upon I1 minus mu2 minus 1 upon R. Therefore, f we obtain as we simplify this equation. Here the LCM is R, therefore mu1 minus 1 minus mu2 minus plus R 1 cancel, therefore mu1 minus mu2 upon R, and reciprocal of this, that gives the resultant focal length f is equal to I upon mu1 minus mu2. Only the mathematical simplification. Okay. Now next 25th, the angle of prism is given E. One of its surfaces is silver. We do the prism. Suppose this surface is silver. That means the reflecting surface. That is the prism ABC. Light is falling at an angle 2A on the first surface, return back to the same path after suffering the reflection at the silver surface. Already this type of the numerical we calculate, but in this numerical we consider the numerical value, angle of incidence and this. So here the one ray of light is incident at an angle 2A angle. So there is the reflected, and after the reflection, incident perpendicularly on the silver surface. So as a result, this incident light is returned back on the same path, because the perpendicular incidence take place. So the reflection is also take place in the same path. So the same path after the suffering the reflection at the silver surface. The effective index M of the prism. Here the A medium N1 or the M1 is equal to 1. Here the M2 is equal to M. The method is same. Already we calculate this step of the two numerical we discussed. So total angle A is equal to I1 plus I2. But here I2 is equal to 0 and I1 is equal to R. There is the R, angle of reflection. There is the P, there is the Q. I1 is R. Now applying the Snell's law at point Q. Applying Snell's law at Q point. Therefore, N1 or the M1 sine I is equal to M2 sine R. m1 is equal to 1 sin I, that means the 2a is equal to m, m2 is equal to m sin I is equal to a. Therefore, effective index m is equal to sin 2a upon sin. Now, from the equation of trigonometry, 2 sin a, 2 sin 2a, that means the 2 sin a cos a upon sin a. Sin a cancel, therefore 2 cos a is the effective index of material of a given prism. Again, first, for a prism we know that the angle prism A is equal to I1 plus I2. But here, the ray of light is incident on one surface of a prism at 2A angle of incidence. After the reflection, it incident on a silver surface perpendicularly. As a result, after the reflection, it return back on the same path. Therefore, angle of incidence I is equal to 2A, angle of reflection is R. Here, incident at 90 degree angle. Therefore, R2 is equal to 0. Substitute here, R2 is equal to 0, R1 is equal to R. In this equation, we obtain the A is equal to R. Now applying the Snell's law at point of incidence. So M1 is the effective index of A medium, and M2 is equal to M, effective index of material of a prism. Now, therefore, M1 sin I is equal to M2 sin R. M1 is equal to 1 sin I is equal to angle of incidence 2A is equal to M2, that means the M into sin A. Therefore, effective index of material of a prism M is equal to sin 2A upon sin A is equal to 2 sin A cos A. Because the sin 2A is equal to 2 sin A cos A upon sin A. Sin A cancel. Therefore, we obtain the 2 cos A is the effective index of the given prism. Clear this? Okay. So, way is numerical, but we have to first read carefully and try to understand what we want to find out. Clear?